Corsa.js.
Well, great. Hi, guys. It's really amazing to see you all today here in person. I'm really glad to be here, and let's start. Today, I'm gonna tell our own story about how we did improve performance for one of the most complicated and biggest really complicated views of our product, that is Rike. And this view is Rike workload. A couple of words about myself, who I am, why I am standing here today in front of you. My name is Pavel. I am working as a software engineering manager in Rike, that is now a part of Citrix. I started in Rike 3.5 years ago as a front-end developer. From the very beginning of my journey in Rike, I was working in the team who started working on this component, workload chart, that I will be talking about today. So I saw everything that happened to this thing. Starting as a front-end developer, and then I made some stuff, some more stuff, and that's how I become team lead at this team first, and now I'm working with two teams, working in one product unit, who are actually both teams working in one single scope, and both teams are working on this component, Rike workload. A small setup, just to make it a bit more clear for you, what is under the hood of the discussion. What is Rike itself? As a product, you can be familiar with it, or you can be not. It's fine. Rike is one of the leading collaborative work management platform. So what does it mean? In general, for doers, for regular users, it's a to-do list. For managers, it could be a list of tasks for their project. It could be a Gantt chart. It could be whatever. So it really has a lot of use inside. And what does it mean for us as for engineers? That is a really complex product, huge product with a lot of micro front ends, with a lot of separate components, and with a lot of business logic and a front end side. A lot of calculation, optimistic calculation, business logic, whatever. To maintain all this thing, how we really work, maybe I'm not the best person to tell it. You can check out this link. But in general, we have really a lot of engineers, 2,500 engineers located mostly in Prague and across Europe. We have 20 teams, and 2 out of these teams and about 20 out of these engineers work exactly on this project I will be talking today. We have 400 front-end repositories for this micro front-end architecture, and I will be talking just about one single repository out of this 400 today. And in total, we have 2 million lines of code just at front-end, and even more. And when it's getting more interesting when we talk about stack, you're really right. So our product in general is written in Dart and Angular. In case of some of you are familiar with Flutter, Flutter works with Dart, right? So we use Dart and Angular. So it's a separate implementation of Angular, not for TypeScript, but for Dart. Last year, Google announced it is going to be sunset soon. So from last year, we start our transition to a new stack, TypeScript and React. Why I'm talking that? Because just for the context, this view, workload chart that I will discuss today, it's written, guess, in Dart and Angular. So when we speak about Angular, when we speak about performance, we recall all the things like change detection, like on-push strategy, some calls outside of zone. So you know, it's all about that, but not else. So what is workload itself? From the product point of view, it's pretty simple, right? So it's like a small table with some dates. You can see all your team over there, a separate swim line for every team member. Inside the streamline, you can see all their tasks allocated by dates. And for each date, you have their, you won't believe, workload, a number that represents effort allocation for this particular day. So basically, that's it. But when it comes to a real technical implementation, what we have here. First, this effort allocation, it's being calculated at both front end and back end. So you can imagine how many cells we have in front end and how many calculations we have every single time when this change detection things work, right? It's getting even worse because we have this calculation for every single row. It's getting even more worse because we have some aggregations over here. For example, these two users, who is it, Kate and Xavier, they could have some job role, for example. Let it be like front-end developer, right? And me, as a front-end manager, I want to see workload for a whole group of front-end developers. So I need some aggregation. And here is how we got this aggregation. But that's not it yet. We have another level of aggregation by projects. So your like front-end developers can work in different projects, and there's more and more and more calculations on a front-end side again. Apart of that, sure, we have infinite scroll. It's like a really fancy timeline. You can scroll to, like your user can scroll to any date they want. From to the past to the future, never mind. You can scroll it how you want, and you have to support infinite scrolling. You have to support paging, and you have to support recalculation on this scroll. Then, as I said, we have some optimistic recalculations and real-time updates. Just imagine, some of our customers are really big, so they could have up to 10,000 users in their accounts, or maybe even more. And when you, as a manager of some team, are sitting over here and looking into this tool, and you'll be like, interesting, what is the real workload of my team? There could be like any number of person outside of your team who are really committing some changes right now. They can change dates of this task. They can change effort allocation of the tasks. And that's why every single moment you can get an online update, real-time update from every other user in your account. We have to apply them. And this, again, it leads to recalculations. One more thing. If you speak about this performance, if we speak about complexity, we have some logic around some interaction about task creation, resizing, and drag and drop. Because as a manager, if you see that your team member is overloaded, you want to take this task and drag it, like to change this date. You want to replan it. This, again, it leads to additional logic and optimistic recalculations for all of that. So, like, plenty of stuff, right? And every single line here, it causes a huge performance challenges, let's say challenges. Basically, it looks like that. So, it's not a big deal. But if you speak about technical implementation, it is. What I will try to cover today is like our journey from this year, starting from January to like nowadays in October. In January, we started having like a first huge wave of escalations that we never had before. We tried some quick fixes. We tried some to set up some performance tracking. We tried some long, expensive fixes, and now I hope we can say that we almost dealt with the all major problems and performance of this amazing view is good enough. So how we even started thinking about performance, right? So how it usually happens in the team. You as a developer, you have a pretty small account. So in our case, it's like 5 users, one task. You can drag this task, fine. You can test all interactions with one single task. You can see effort allocation numbers, fine. That's perfectly enough. Why do you really need, in a test account, really big amount of data? Like, nobody does it, right? Second thing, we had pretty performant MacBooks, so why should it be slow at all? And when customers start coming to us, we were like, but it's fine for us. Why are you complaining? It works for us. What's your case? Then a couple of other factors that the product RIKE itself and our workload started growing really rapidly. We were introducing new features over and over again, and that's how we dramatically increased our complexity, and that's how we missed some things about performance. And sure, company also experienced some growth, and it led to the fact that we got much more enterprise customers. And who are enterprise customers? They don't have like 10 or 20 people in their teams. They have thousands of them. And they want to see this workload for the thousands of people. That sounds like a really big challenge. So starting from January, we started getting performance escalation, as I told, 10 in January, like comparing to 0 in December. Something went wrong. So if you remember some events from this March, it looked like that. We started trying to understand what is happening, why is it happening. But like one task, performant MacBook, everything was fine. And we really didn't understand what was going on and how to fix it. So what we did, what was our case? I guess the main thing I'll try to cover today is really our experience and things that we learned. Maybe there will not be any major tricks, any major advices for you, but at least experience, I believe it's really valuable. So what we decided to suspend all of our releases. So it doesn't matter if we release any new features if users cannot use them, right? If this tool, it cannot be opened at all. It just stuck during loading. It doesn't make any sense how much features we have. And we took one single month to focus both teams, like 2 sprints of both teams, to fix these issues or get a further more reliable plan. So our first assumptions and attempts to fix it were like that. First of all, we started thinking about the amount of DOM elements. Like it is really crazy. When you open recommendations by Google, they said you should have around like maximum 1,500 of DOM elements in a page. We having this pretty fancy grid of day cells, especially for 4K displays or even for full HD. We got, you see, 45,000 of DOM elements. It's done a lot, really a lot. It leads first to huge memory consumption and then to CPU consumption because every single cell, it contains a number that should be recalculated. That's crazy. Second thing, we blamed our client-side calculations because you can see even for a really simple interaction like drag and drop, we had this optimistic rescheduling of a placeholder. So you can see at a task of 3 days, it jumped to 5 days because it contains now a weekend inside. Right? So we have to recalculate work schedules according to weekends, according to all PTOs, like the whole work schedules. So we started thinking about, should we drop some optimistic recalculations? And then again, back to this slide. Like, this is crazy. Like, what could go wrong with this setup, right? And actually a plan that we got, we wanted really to understand what exactly is going on a customer edge, on a customer side. What is happening here? Because for us, it was less or more fine. We, as a development team, as a user of workload, we used it every single day at daily stand-ups. So we experienced some minor troubles with performance, but we could use it. And it was not a showstopper for us, but it was for them. So the first thing that we tried, we sent developers to customer escalation calls. And that's exactly how we discovered this interesting problem with 4K displays. Because from the very first second of this call, when they started screen sharing and we saw this huge viewport, it was pretty clear for us what was the problem. We don't have like 4K displays in a regular life for testing purposes, but they have it in their real life. The second thing that we did is we understood that maybe if it is fine for us, we should really track some number. We should track performance. We should set up a metric that is being calculated on a customer side. So that's how we came up with an idea of performance tracking. It's like really pretty simple, like some code samples. As I said, we use Dart and we use Redux under the hood for state management. And we introduced a performance tracking middleware. It's like pretty simple. It's configured with these events. So as you can see here, it takes start action and finish action. In the middleware itself, we defined the most important events for users that really created a journey of user. So like row expansion or drag and drop or scrolling or something else. And we defined all events for these users. And like basically that's pretty much it about this middleware. It just started tracking when it received start action, and it ended tracking when it receives the end action. So basically it looked like that. 2 timestamps, and the difference is the time of execution of this operation. And when we got these numbers for all of operation, what we did, we set up the metric. The metric was Abdex. Abdex is application performance index. And this is the key thing of the whole talk, of the whole our journey about performance improvements. Abdex really helped us to understand the real picture for each particular customer, for every setup they have, depending on number of people, number of workload members, number of tasks, number of projects they display. And how we approach it, first we prepared a list of operations, as I told, like really major things. When a user starts opening workload, like start scrolling it, doing some interactions with tasks, all those actions were included into Abdex list. Then we set target timing. For example, I don't know, for row expand operation, when user click on on swim lane and it should be expanded, it was maybe around 100 milliseconds. So like that. We actually did it together with our UX designers, so we could understand these 2 major thresholds. What is a good timing, what is a fair and a poor timing. So like T1 and T2, it's like 2 borders. Then we try to understand the priority for these operations, and out of our interviews with customers, out of our own experience, we understand that the most important things were initial loading of this chart. It was recalculation, like invalidation of a viewport. It was drag and drop, and it was scrolling. So we included this high priority operation into this Abdex, and it's basically how it's calculated. It's an aggregation of number of good performance events and a fair performance events, according to this formula. And we divide all this thing by total number of events. So as an output, we have this scale. So like everything is above 0.85. It's good. It works. It's fine. It shouldn't cause any escalations. But everything that is above that is above 0.7, it's not good. We even if we haven't got any escalations about that, we will, and like pretty soon, and we had. We actually had some basic implementation of performance tracking for a while, for a few months, and that's how we saw our Amdex when we configured it, and it was really, really bad. As I told just now, like poor performance is under 0.7, right? Here you can see that it is poor. So it's not a case. It really didn't make any sense to introduce any new features because it's unusable at all. And why should they pay us such a big money for any new stuff when like an existing stuff, it's not working? So what we tried, in parallel with this performance tracking, in parallel with like big and really expensive fixes, we started big fixes first. So no rocket science here. First we went to Profiler, and for example, that's how looked before and after our interaction about drag and drop. So like I made a demo of this GIF with drag and drop a few slides back. That's how it worked from Profiler. So we eliminated some unnecessary recalculations. For example, it was pretty nice to see it for year-long tasks. In a real world, most likely customers don't have 1 year-long task. It's like almost doesn't make any sense. But in testing environment, you see 1 second versus 7 seconds. It really helped. Well, the next thing, if you guys are familiar with Redux, I'm sure you are, you know there are some practice about selectors, just to not to work with the state like explicitly. And even though, even if you need some calculations on the flight out of the state, you really selectors it's exactly the thing that perfectly fits you. If you are not aware about that, like you can read over this link, and the thing that is makes this really faster is memoized selectors. So it uses some cache. It's a pure function, right? It gets same input, it gets the same output. So we can set up some cache so that we can avoid unnecessary recalculations here. We have this in like TypeScript world. We do have this in Dart world. The only problem was that we actually didn't have a support of a deep memoization. And that's why like we introduced this thing. It's like our own wrapper over a Reselect library in Dart that's published in open source, and it supports deep caching. So we tried that, and it was really also useful. For example, for a bar drag over event, after some of changes, you can see that Amdex was already significantly increased from 54 to 94%. It's like almost everything was solved, right? And another interesting chart at the right side, it's about pre-recalculation event. It's you can read it as invalidate viewport. So this is a chart for a number of this event. So you can see that before our quick fixes, it was a like huge amount of these events. The viewport, it was invalidated for every single interaction. Now it's not, and it became really much more faster. And then finally, like the most expensive and most interesting stuff, because even though we introduced all these changes, it didn't help a lot. It added maybe, I don't know, 3, 4, 5 points into our AppDex. So it wasn't a solution. We still were in a fair performance, not good. So our plan was the following. We understood that our product is complicated. Maybe we can challenge this business logic and we can get rid of some things. The second part of this plan was to introduce some expensive technical improvements that we already understand that we have to do that finally. So getting to examples. This example, I really love it. What is it about? We have, at the bottom of the chart, we have a backlog box. So how does backlog box work? In any product, it has some unassigned tasks. So you as a team, as a manager, or as whoever, you can go to your backlog and assign tasks to people. And our initial logic, our initial idea was to have this, have in this backlog box, have all the tasks from the account. And it was exactly what customer wanted. It was exactly that what they asked for. But there was a little problem when we came to enterprise customers, right? Because it worked fine when they had 20 users in account who were generating a lot of stuff. It became a problem. So what we really tried, we tried to change this logic and display in backlog box just the task from the scope of the chart. It's a major change, change of logic, change of what customer asked for, but it worked. It worked perfectly fine. It was helped a lot with the backlog itself, and it's also been validated with customers, and they were perfectly fine with the change. So why I love this example, nothing is set in stone. You can really change things even outside of technical improvement, pure technical improvement, I mean. Another experiment that we have, this is an experiment. This was not released by, we tried it. We understood that our scroll is really, really heavy. It was heavy. And we understood that it was about, it was because we had to recalculate a lot of stuff during scrolling. So an idea was pretty simple. You need scrolling, please scroll. You will not see any data, but it will work much faster. So in a really couple of days, we implemented this experiment. We released it under some beta flag, and we enabled it for several customers who had the biggest complaints about scrolling experience. And it was interesting. They said that yes, scroll works fine now, but we do need these tasks because we don't just scroll to any date. We have no idea about dates. We remember that they had some tasks somewhere, and we're really seeking for these tasks. So we have to see these tasks. And it was sad, but finally we ditched this experiment. It was not released. Another experiment was about online updates. I already tried to introduce this logic, so how it works. You sit in your chart, and you have 10,000 of your colleagues who are committing changes into these tasks. And all these numbers, all these tasks, they are getting more and more updates over and over again, and everything is being recalculated. And our hypothesis was that why do we really need this? And our experiment was about getting rid of this online updates at all. But what we did, we introduced this refresh button, that actually can get your updated picture in any time you want. So if you want to just go into the chart and get a weekly report, you don't need all these real-time updates. You can use this refresh button. And we, in our own account, we also have pretty much users. So what we did here, we enabled this feature for our own account. And after that, we After that, we tried to generate these online updates by ourselves. So we collected a team of like a lot of people, and we assigned one person who was sitting and clicking this refresh button, pretending to be a user of workload, and who also was measuring a performance of all interactions. And all others were like just dragging tasks like crazy and generating a really huge amount of updates. And it shows us that it was not the case, actually. If the chart is properly set up, if a viewport is just for some particular dates, it doesn't make any sense what is happening in other parts of this viewport that are out of screen. It doesn't make sense what's happening out of chart scope, so it worked perfectly fine, and we also did this experiment. But it was interesting. And like my favorite thing here, when we started Workload 3 years ago, we aimed to support like infinite scrolling, so horizontal virtualization, and also vertical virtualization, so that we could display like hundreds of users, really hundreds of users. And it worked perfectly fine until we got this nested rows, until we got hierarchy. I don't know why, like nobody does, but we made really simple mistake. We forgot to support this virtualization for nested rows, and look how it worked. In a viewport, there was a user with like 51 projects underneath. 51 projects underneath this user. And vertical virtualization, when it came to it, it took these rows and said, okay, I have one single row for user. I will show it like the whole row. And it rendered all 51 of nested projects. 51 rows of nested projects means that it's really a huge amount of cells that should be calculated, huge amount of tasks that should be requested, and it ruined everything. So instead of 5 projects, we showed 51. It's like an edge case, it's a testing environment, but anyway, in customer accounts, it also could be a case. For example, we have some customers who have, they have a separate project for every single how to say it, every single deal. So when their own customer came to them, and when they have a deal, they have a small, tiny, really tiny project for that. So they could have like hundreds of such projects. And that's why it failed. And actually, yes, like 2 more minutes. Yeah, thanks. Actually, it works perfectly fine. So here are like a list of what we tried, like quick fixes, long fixes, experiments, changes in product logic. You see, if you can see scroll, it's like half of this list. So it was really a huge amount of things. And as a result, what we got during like over a couple of months, our performance became at least fair, and it went to even some good state, like more than 0.8. And at the bottom chart, you can see that green line, for example, it's Abdex for a big account, and it was really a pain in January, but it became much more better now. So it's like basically stats for our events. You can see we have a lot of events above 0.9, but we still have some troubles with several events from this list. And what is next? Just want to share our future plans, but really want to ask, what do you guys think, like any random ideas? What is the most performant tool in the world? Kind of, but yeah, you're running a bit ahead. What is, I'm asking about a tool. What is the most performant tool application in the world? How do you think? Excel, who said Excel? Yeah, so yes. Cool. Yes, it is Excel. And if you guys ever tried to look how Google spreadsheet are realized, they use Canvas. So they have the same crazy grid, like huge amount of cells, huge amount of everything. But they use Canvas and it works perfectly fine. So our next plan is to switch from DOM to Canvas. Yes, exactly as I said. And also leverage Excel in other way. We'll just export this data to Excel and let them slice and dice this data as they want. Because it's really impossible just to cover some edge cases with huge account and huge setups. So here is the QR code to the article about this talk. If I didn't cover anything, so you can find details there. And also you can post your questions as a comments. I'm sure I will answer. And like as an outcome of this call, of this talk, so what, if I did this again, how I will approach it, that. Sure, I will start from the profiler and check CPU and memory consumption and Deacon site. Check my DOM nodes counter and make sure it doesn't exceed 1,500 of DOM nodes per page. I will try to set up a performance tracking and updates to understand the real picture from customer side, because I can have a good performant MacBook, but they don't. And if I use Redux minimizing selectors, I won't be afraid to run any experiments with features to get rid of them, simplify features and business logic. For any detailed layouts, I will use Canvas instead of Zoom, sure, instead of Zoom DOM. Like as a wish, I would say I wouldn't build any universal tools anymore. It's impossible to cover everything in one single tool, but really it's better to limit yourself to some particular cases and make sure they will work perfectly fine. That is it. Thank you very much, guys.
Thank you, Pavel. Thank you so much. We have at least one question from the room today. So yeah, let's hear the first.
Thank you. Very interesting talk, and I'm supporting you in optimizing your rendering. I think you should consider. Have you heard about hands-on table?
Yes.
So I think you instead of thinking about instead of thinking about implementing this as an Excel canvas, I think you could just get hands-on table, because they have magnificent internal implementations for rendering, and also their architecture is wonderful for integration. And also, I think up to version 7 they were even MIT licensed. And I think Excel is implemented with Canvas because they need to handle all of the devices. And if you have if you know your customers, then most probably they have browsers which implement intersection observer. Therefore, you can take advantage of modern, based on virtual DOM frameworks. So I think hands-on table might save you many years of work, and good luck. Thank you for your talk.
Yeah. Okay. Yeah. Thanks for the comments. We actually considered some like third-party solutions, but every time when we think about it for any other use, we have like basically a table view in Rike. We have a Gantt chart, but all this view were implemented from scratch because we have like huge amount of custom logic, and this logic really makes a difference. And it's really pretty hard to implement this logic in some third-party solutions. So yes, we do have implementations of like many things made by our own. Yeah, thanks for idea.